Hydrates are ionic compounds that have water attached to them, and it's called a hydrate because it's hydrated. It has waters attached to it, and so the front part is always an ionic compound, and the second part is always an amount of water. This dot in the middle means attached. The water is added to it. I know in math this big dot can mean multiplied, but not in this case. It just means the water is attached. So opal is an example of a hydrate. It's silicon dioxide and it has one water attached, and then that one water makes it sparkly. That's why it has its sparkly look. Why do we use hydrates? Or actually, they exist in nature. It's not like why do we use them? We use them. They're used as drying agents. They can absorb water. They're used that's a big use. They're like, do you know, like the way diapers absorb like pee? That's because they have a hydrate in them that it can absorb a lot of water, and that's one of the compounds in diapers. How do we name these things, and how what do we need to do with them? Well, we're doing a lab. We're doing a virtual lab next time with a hydrate, so we kind of have to know a little bit about them. So when you're naming hydrates, you write the name of the first part. It's called the first part that has no water is called anhydrous. And in English, when you add the prefix an, it means without. So without water, the first part, like this sodium carbonate, is the anhydrous part. It's the part that has no water. Okay, so you just name that normally the way we've been doing. So this is just sodium carbonate. And then I come to the waters and I say 5 is how many? 5 is penta. Pentahydrate. So sodium carbonate, pentahydrate. That's how I name these. Here's a list of all the prefixes we use: mono, di, tri, tetra, penta, hexa. There's not anything different. We're never going to get to 13 and 14. This is just, it's just there. So here's the generic format. The front part is ionic compound. The dot it means attached to. The N tells me how many waters, and then the water is called the water of hydration. So what do I need to do with these? First, let's figure out the molar mass. The molar mass isn't really anything different. I just add up the anhydrous part, 3 sodiums, 1 phosphate, and 4 oxygens, and then the mass of 4 waters, 4 times water. Okay, and I add that up and it comes to 236. How did I get water? Well, water is 2 hydrogens and 1 oxygen. 16 and 2 is 18. So 18. Okay, and then how about this? What goes next? Well, this here, what I'm going to teach you now is setting up for the lab for next time. This is percent composition in the hydrate. You can see when you look at the hydrate that the water is a separate part. Okay, and that we can figure out the percent water in a hydrate. And so how we do that is we say the percent of the water is the total mass of all the waters divided by the total mass of the whole hydrate. So let's do an example. So an example is, the first thing is you write down the formula. Iron 3 chloride, that means iron with a +3, chlorine is a -1, I crisscross, so FeCl3, and it says trihydrate, that means 3 waters. I find its molar mass. Iron weighs 56, chlorine weighs 35, so 35 times 3. 3 waters weighs 3 times 18, I add that up, and it's 216. So the percent of the water is going to be the mass of all the waters, 3 times 18, 54, divided by the mass of the whole hydrate. And so it's 54 divided by 216, and it's 24.97%. Okay, so next time we're going to be talking about, we're going to be doing this hydrate, and we need to be able to do the stuff we learned today to be able to complete this work. This is page 18 in your packet, and I'm going to solve a problem here to help you solve problems. It says the compound in question 1 is a hydrate because 1 mole of magnesium sulfate crystal absorbs 7 moles of water, and it's written like this: magnesium sulfate dot 7 waters, and we'd say magnesium sulfate heptahydrate. Find the percent of water. Well, the first step is, let's find the molar mass of this. Magnesium weighs 24, sulfur weighs 32, 4 oxygens weigh 4 times 16, and then 7 waters is 7 times 18, and it comes to 246. The percent of water is going to be the mass of all the water, which is 126. divided by the mass of the whole hydrate, which is 246 times 100, and it's 51.2%. Okay, and this is pretty simple, but this will help you become familiar with hydrates, and we need to be able to do that because that's the lab that we're doing next class. Thank you.